Today we are going to be looking at symmetry, and I'm sure that you guys are all familiar with this at some point or another. I'm going to do it a little bit differently today. As you can see, I'm actually on the screen with you because I want to be able to use my hands, and I can't really use my hands when I'm just recording the screen itself. So as you guys look at this, one of the keys for the line of symmetry, a figure has line symmetry if the figure can be mapped onto itself by a reflection. So what we're looking at is when we look up here at the top at this triangle, if we draw a line straight up and down, this side would fold perfectly onto this side. Another way to look at this is I went ahead and copied and pasted this earlier. If you notice here, I can go ahead and take and flip this. In this case, I'm going to flip it horizontally. It looks exactly the same. Now, that line does not have to be straight up and down. It can be sideways, it can be at a diagonal, as long as the left side folds perfectly onto the right side, or vice versa, you are good. Okay, so that is your line of symmetry. So when you look at this, here's the key. You want to think of a mirror image on each side, or if you reflect it from one side to the other, it looks exactly the same. Now, when you look at point symmetry is a unique case of rotational symmetry. So what we're actually going to do first is define the rotational symmetry. So if you notice here, a figure has rotational symmetry if the figure is mapped onto itself by rotating the figure less than 360 degrees about a center point. Now, I'm going to go back up to the triangle for a second. If we notice right now, this green dot is at the top. If I spin this, it doesn't look the same as my original, it doesn't look the same as my original, it doesn't look the same as my original until I get all the way back to the beginning. That one does not have rotational symmetry because it took us 360 degrees to get back to that same look as what we started with. If we look down here, we can spin this ever so slightly and all of a sudden it still looks the same as the original. If we spin it less than 360 degrees and it looks the same, it's going to have rotational symmetry. And that's why down here at the bottom it says think of a pinwheel. If you can spin it at all and it looks the same, it has rotational symmetry. Now, with point symmetry, this one has a specific rotation. So rotational symmetry is any rotation less than 360. Point symmetry is, notice, 180 degrees. So if I look here, this means it looks the same upside down. So if we take a look at this N, we can literally turn it on its head and it looks exactly the same. If we go back to our original with the sun, if we look here, we can spin it exactly upside down, and this one also has point symmetry. Now, because of how this is defined, point symmetry, as soon as you have a figure that has point symmetry, it automatically has rotational symmetry. Rotational symmetry is not the other direction. So for example, if it has rotational symmetry, it does not guarantee point symmetry, okay? Point symmetry automatically guarantees rotational symmetry. So let's take a look at some examples together. If we look at number one, basically notice it says determine if the figures have line, point, and or rotational symmetry. So you can have multiple answers here. So if we take a look at this, the line of symmetry it has because we can go straight down the middle this direction, we could go straight down the middle this direction, we could go diagonally. There's multiple going on. So because we have multiple options going on, it does have line. Point, remember, point means it looks the same upside down. So if you were to spin that upside down, it does look the same. So we would have that. And again, as soon as we have point, we automatically have rotational. So we are good there. If we look down below at number three, this one is tricky. Okay, a lot of people want to say that they have line symmetry, and some people will say that it's here. And pardon my rough drawing here, but if you notice, this side is much longer than this side. Same thing here, this side is much longer than this side, or this point doesn't have another acute angle to reflect onto this way. And then some people might say that it looks like here, let me actually do a straight line rather than just kind of eyeballing it here. Some people say that this line is the line of symmetry. And if I take a look at, let me cut and paste this here really quickly so you guys can see this. If I take a look at this, you guys are going to notice as I spin this, if I spin this vertically, this angle doesn't have anywhere to go to on this side. So therefore that line isn't a diagonal. And then some people will say, okay, those might not be, but what about if I were to draw a line going this way? And if we notice that way, again, we're going to have that same problem that we had before in terms of the acute angle versus obtuse angle. So if we look, we can go ahead and we can spin this here. We have an obtuse angle here that doesn't have an obtuse angle to reflect to over here. Same thing with acute over here. That one is probably the hardest. So therefore, it does all that to say this. It does not have line symmetry. However, if you spin it on its head, it does look to be the same, and so therefore it has point and automatically rotational. Okay, try out number 2, and then also try out number 4. All right, so hopefully for number 2, you realize it has line. It does not have point because right now the point is on top. If you spin it upside down, the point would be on the bottom. It does have rotational. This number 4, there is no line of symmetry, and there are no rotational symmetries that work, so this is actually none. If we take a look at number 5, we do have line symmetry. We have some going up and down. We have going through the point here. So we have line. Again, point, if we spin it upside down, this top does not go, or excuse me, the top is pointing up right now. If we spin it upside down, it'd be pointing down. So it doesn't have point. However, it does have rotational. And then number 7 does have line. However, it does not have rotational. There's no way you can spin it and it looks like that A until it gets back to the original. So do me a favor, try out number 6, try out number 8. Let's see how we are. All right. Okay, so now when we look at this, number 9, I'm going to go ahead and go through a couple of these with you here. I'm going to actually go ahead and cut and paste number 9 just so you guys can make sure you see this one. All right, number 9, if we take and we spin it, it looks the same before we get back to the original, so we know we have point. However, it does look the same upside down as well, so we know that we do have rotational as well. So we can go ahead and do point, rotational, and then number 10, we're going to just go over here to the right. It does have line. There's one going up and down, one going side to side. So it does have line, but it also has rotational and point because it looks up the same upside down. Number 11 doesn't have any, actually. So we're just going to go ahead and select none. 12 does have line going straight through the middle. You only need one line for it to work. And as far as point and rotational, it does not look the same anywhere when you rotate it. Okay. Now, what I want for you guys to do is go ahead and try out the remaining. So you have 13, 14, and then you also have 15 through 20. Do that before you get to class today because we're going to take the very first part of class to give us a just quick thumbs up and thumbs down for all those checkpoints and make sure that we are on the same page. Okay, so please be sure, have those done beforehand so that way we can go through those fairly quickly. All right, guys, let me know if you guys have any questions. Again, this is one of those things. I tried something different today with the video embedded rather than me up at the screen. So hopefully me being able to talk with my hands a little bit helped. Let me know. All right, thanks.